Hey everyone, it's Miss Gubrud. Today is lesson 2-5A, the first part, and we're talking about choosing the right dimensions and the right formulas. Dimensions in math means distances. So we're going to talk about how to choose the right distances on 3 different shapes. We're also going to talk about choosing the right formula for how to solve those problems for area and perimeter. So we're going to talk about triangles, we're going to talk about rectangles, and we're going to talk about parallelograms. Now, we've had all of this in previous lessons, so this lesson is a little different. You can just go ahead, turn me off right now, and do the whole lesson today. If you get stuck, though, go back and find in the video the part that you need to start on and start watching forward. So most of the time I say you need to watch the whole video. Not so today. It's a review to help us choose the right dimensions. Are we going to choose the number that's on this side? Are we going to choose the number on this side? Are we going to choose the number along the bottom? Or is there a number in the middle? Sometimes there's a number out on the outside edge. So the dimensions, we're going to help you choose which ones to use, and then the formula for area and perimeter, which I actually don't have written on the board. Okay, so pause the video, open up your book to page 73 and take a look. Wow, that's not in focus, is it? And take a look at it. Try number 1, and then come and watch if you don't know how to do it. Try number 2, come and watch if you don't know how to do it. Try number 3, come and watch if you don't know how to do it. Number 4, weirdly, is connected to number 1. So maybe you want to try 1 and 4 at the same time, and then 2 and 5 at the same time, and 3 and 6 at the same time, and then do that same pattern down below. So you're going to do 2 pages out of the lesson, not the whole book, just 73 and 74. So come on back if you get stuck, and I will help you through those problems. Good luck. All right, we're back. Let's talk about these, remind ourselves of how to find things and the formulas. So let me move myself. Oh yeah, there we go. There, lets me move myself. All right, so perimeter for any single shape. Perimeter is always the distance around the outside edge. Perimeter person. Did your perimeter person skate? Did they skateboard? Did they run? Did they jump? Did they fly with rocket boots? Did they ride their bike? Did they ride their horse? Did they drive in a car? Your perimeter person drives or walks or runs or whatever all around the outside edge. The perimeter is always the distance around the outside edge. So you have to look for the numbers that run right along the outside edge of the shape, no matter what shape it is. Area of a rectangle. All right, here it is. I'm going to move myself again a little bit there. The formula for the area of a rectangle. A rectangle. Base times height. Remember, those are different words. You've used length times width before. Don't let those words confuse you. Those are words that we used in years ago. Now, starting in 6th grade and going on and on and on, we're going to use base, what it's sitting on, times height, how tall it is in the air. The area for a rectangle, base times height. Area for a parallelogram. Now, you've done this with me in small group. You know that if you cut a rectangle at a weird angle, we're cutting that pizza. We have a weird pizza cutting disaster. We cut it at an angle. We flip it around. We make a parallelogram. Here we are. We did it in our small group. Here's our rectangle. If we randomly, it has to be a straight line, at a diagonal though, if we randomly cut a rectangle into a diagonal and switch them around, we made a parallelogram. Did we change the surface area? Not in any way. Nope. Same amount of pizza sauce, crust, and toppings are on this pizza as are on this pizza. So the amount it takes to cover the surface, same. How did we find area of a rectangle? Base times height. How are we going to find the area of parallelogram? Base times height. But you just got to remember, what's the height? All right, take a look at this. The height is from the base all the way up to the top. It's not the side angle. We don't measure like this. It's not the side. That's just one of the sides. The height is a perpendicular line, means it's a square corner from the bottom straight up to the top, just like me measuring how tall I am at the doctor. Okay, so there's base times height, area of a parallelogram. Whoops. Area of triangle. Triangle. Remember, we cut paper for that one too. We did that in an earlier lesson. All right, right triangles. We started with a rectangle again. We cut diagonally from corner to corner. Here we go. Now I'm just freehand cutting it, but it'll be okay. It'll be pretty close. Here it is. So there's my rectangle. I cut it. Look what happens. I have two exact right triangles, but I have two of them. So, whoops, there we go. So, if I have a right triangle and I'm trying to find the area, what do? I make it back into a rectangle, so I draw on a second one. So if I start here, I draw on a second one. Now it's easy, base times height. But then I have to cut it in half again because I only want the area of half. So the area of a right triangle, 1/2 the base times the height. What's the height? Don't get confused. There's the base. There's the height. Not that diagonally line. That's not the height. Base times height, but then you got to cut it in two because base times height gives you the rectangle. What about a different triangle? We talked about that in a lesson as well. All right, remember those purple and blue triangles that you cut out and flipped around? So I've got a big one here. So here's a not right triangle. This is an acute triangle because all of the degrees are all acute. So I've got an acute triangle here. How can I find the area and perimeter of this? Well, perimeter, same thing, all around the outside edge. That's where perimeter person walks. But area, remember, what happens if I make a carbon copy of this one? I pause and make an exact duplicate of this triangle. All right, I just cut out an exact duplicate. So these are exactly the same. Now I have two of them. Just like what we did in our lesson, match up two of the sides that are the same. Look at this. What shape have I made? I made a parallelogram, didn't I? Look at that. If I can take two triangles and put them together and make a parallelogram, I can use base times height because I know that a parallelogram is base times height. But before I find the answer, what do I have to do? I have to get rid of this second copy. I only want one. So for the formula for any triangle at all, you make a second copy of it, tip it upside down and make a parallelogram, do base times height. Then you got to get rid of a half of it. So it's a half of a group of base times height. 1/2 times base times height, or base times height divided by 2. Now remember, don't get tricked by the height. It's easy to know what the base is. The base is what sits down on the bottom. There it is. There's the base. The height, though, it's not that angle. It's not the other angle. It goes straight up from the base. It runs at a perpendicular line straight up from the base to the tippy top. So make sure when you're looking for the height of any triangle or the height of any parallelogram, you're going straight from the base surface straight up to the tippy top, and realize that sometimes that actually might be out away to the side, which gets tricky. Good luck. Well, I can't find my mouse. There we go.